Hello everyone, I am Anushka Srivastava. Welcome back to my channel. So this is my 10th lecture in my data science playlist. Let's see what are the topics that we are going to discuss today. Our topic is dimension reduction. Now let's see what do we mean by dimension reduction. Dimension reduction in data science refers to the process of reducing the number of features in a data set while retaining as much important information as possible. This is particularly useful when dealing with high dimensional data, which can be difficult to analyze and visualize due to the curse of dimensionality. Dimension reduction helps simplify complex data, high dimensional data sets, making it easier to analyze and interpret the data while improving performance of model. It is a critical step in data preprocessing for many machine learning tasks, especially when dealing with large or unstructured data. So let's discuss when to use dimension reduction. Dimension reduction is a powerful technique in data science and machine learning. Here are some scenarios and consideration for when to use dimension reduction. Number one, high dimensional data. When you have high dimensional data, use dimension reduction. Number two, noise reduction. Number three, improving model performance. Number four, computational efficiency. Let's discuss some of the dimension reduction techniques. They are principal component analysis, autoencoders, linear discriminant analysis. So, what do we mean by principal component analysis? PCA is a linear technique that transforms the original features into a new step of orthogonal features called principal components. These components are ordered by the amount of variance they explain in the data. We use them in data visualization, noise reduction, and feature extraction. Advantages of PCA is it is simple to implement, interpretable, and effective for linear relationship. It is effective for linear relationship. Disadvantages are assume linearity and may not capture complex relationships in data. Second type is linear discriminant analysis. LDA is supervised technique that find a linear combinations of features that best separate two or more classes. It maximizes the ratio of between class variance to within class variance. Classification tasks, especially when the goal is reduced to dimension while preserving class separability, we use LDA. Advantages are effective for classification problems and interpretable. Disadvantages are assumes normal distribution of feature and equal covariance among classes. Number 3. Autoencoders. Autoencoders are a type of neural network designed to learn efficient representation of data by compressing it into lower dimension space and then reconstructing it. They consist of encoders and decoders. They are used in image compression, denoising, and feature extraction. Advantages of it are can capture complex nonlinear relationship and can be tailored to specific dataset. Number 4. Disadvantage require more data and computational resource are the architecture can be complex. Benefits of dimension reduction are as follows. Number 1. Improved model performance, noise reduction, easier data visualization, and reduced computational complexity. Types of dimension reductions are as follows. Dimension reduction techniques can be broadly categorized into two main types, feature selection and feature extraction. Each type has its own method and application. Here is a detailed overview of these categories and their associated techniques. Number 1. Feature selection. Feature selection involves selecting a subset of the most relevant feature from the original dataset without transforming it. The goal is to retain the most informative feature while discarding irrelevant or redundant ones. Feature selection can be further divided into three approaches. Number 1. Filter method. Number 2. Wrapper method. Number 3. Embedded method. Now let's move forward to feature extraction. Feature extraction involves transforming the original features into a new set of features, often in a lower dimensional space. This process can capture the essential information while reducing dimensionality. Common techniques include linear technique, nonlinear technique, neural technique, and matrix factorization technique. Thank you. Here I am ending my lecture. I hope all your concepts are clear. See you in the next video. Bye bye.